Hey everybody, hey, how's it going? Dr. Johnny T here, and we got Jared. We got none other than James,
the amazing
running the
James.
Boards. Yeah, that's right. We're going to be talking today more about GMP, the thing that everybody likes to talk about when they think about GMP.
Yep.
Layout. Equipment layout.
Yeah.
Everybody think, okay,
Very
GMP,
important.
well, I have a layout, I must be GMP. Okay. But we're going to do that today. We're going to talk a little bit about the layout, something that we have a lot of experience with.
Oh, yeah.
Mostly because we put the equipment in there and we're also subject matter experts in our field. Yeah. So we know where, how everything goes together.
We've helped, set up facilities straight for GMP and then other facilities not for, and then they want to do GMP, and you realize the headache that is involved when you try to do something like that.
Yeah.
It's almost impossible in some circumstances.
Yeah, exactly. So some buildings just don't work. Some facilities just don't work. A lot of different things. Maybe you can't get the permitting. Maybe it doesn't. Maybe you're too close to a chicken farm. Or a chemical plant.
Yeah.
Well, it's too close. We might have a little crass contamination here.
Right. Have you ever had an issue like that or heard of one?
In rural areas, sometimes there's soy extraction places and things like that, or ethanol extraction places. You want to stay away from them.
Okay.
Because there's a lot of VOC. If there's a lot of VOC, the issue is that all your air intakes from your HVAC and everything, it's hard to get that all filtered out. You can do HEPA filters with great MERV ratings and everything and all this crazy stuff. But if you have outside VOC issue, how do you really control that?
Sounds expensive.
Yeah, exactly. So you have to have advanced filtration and everything. So we're going to be getting into that a little bit. But before we get going, we have the resources for you. We've been working real hard.
Always, nonstop.
The courses really focus in on conceptual items related to like extraction or distillation or something like that. If you want to do like training on equipment and stuff like that, buy some equipment and you can come here. And we've had people do that before. Some of our European clients, for example, they'll send people here and they'll spend a week or 2 weeks getting to know. We put them to work.
But
it's great. We work them real hard.
That's how you learn, though.
Exactly.
Yeah, somebody took down the damn burger
at
the
did
Dallas
take
house.
the damn burger down.
Yes.
Oh man, how do you do that? Anyways,
I don't know.
We've all seen this. We've talked about it so many times.
Oh yeah.
This is the basic layout for the process for creating APIs. You have your inputs, which are your raw botanicals, your solvents, your cleaning materials. You could add into that now people. You can add in facilities. You can add in now the environment. And actually, there's many layers of complexity with this, but just try to keep it simple. Basically, you have inputs with API outputs. API outputs meaning active pharmaceutical ingredient. Output, and those, in our case, may or may not be cannabinoids, or they may or may not be distillates, but they could be other things, beneficiated oils, flavonoids, anything with a chemical specification. We talked extensively about chemical specifications, remember that? And how that's important when you got to really define all that stuff. Got some formulations, you add those cannabinoids in with the formulations, then you get final dosage forms, and then you go into the packaging. So we've been talking about these subjects for several weeks now, going through the Q7, which is the ICH GMP, the good manufacturing practice. We talked about codified into law in Europe, its guidance in the US. It still is used. We've actually read from the Q7. So if you guys get a chance and you want to go to sleep, we've got a lot of really good items in there. One of the things that you really need to think about when you got about a layout is you need to follow a development process. And we have talked extensively about the process of creating a layout. So far, we've talked about a risk assessment. We've talked about identifying critical processes, critical steps in the process. We've talked about external contamination, internal contamination. We've talked about cross-contamination. Remember all those? We've talked about cleanability, maintenance, maintainability.
Because it all plays into how you produce your product.
Absolutely.
Which is essentially your proprietary recipe.
Hopefully we're cross-contaminating your mind right now.
I like that.
All those little mind viruses. They're coming out to you. But typically you want to follow a development process so that when it gets reviewed, you can say, hey, look, we developed our building, we developed what we did here, we developed it according to a process. It has a risk assessment behind it. It has all the critical aspects of what we consider to be critical and not critical. And therefore you have data and backup for what you did and how you actually ended up with what you have, which is a production facility.
Right.
A lot of people don't go through all the homework up front.
No.
And then they're just creating it, and then they don't have that, and then where's the risk assessment? They're trying to do it in afterward, and then it doesn't really work. What we like to do is a feasibility study. We like to have feasibility on paper. We do some concept planning.
Right.
This is just a general thing of what you want to do. System design, building detail. That's where you really spend a lot of time engineering with engineers. It takes a lot of work to put together a plan.
Yes.
Believe you me.
Yes.
It really looks simple, but if you want to have a full plan that takes into account all the workflows, all the personnel flows, all of the fire codes, all of the utilities and how they interact with one another, adjacency and all that, you really gotta, sometimes it takes a little while, even because A has to be connected to B, and B has to be connected to C, but C can't be by A.
Right.
There's all kinds of stuff like that.
Lots of little weird things
Yeah,
that
you got to
make it difficult.
You got to do the work. Right?
Yeah.
And interestingly enough, everyone's a little bit different. So it's a lot like your typical architectural thing.
Yeah,
I mean,
layout.
it's not like
every
you're gonna make
building
one
is
plan.
shaped differently.
Yeah.
Different rooms within buildings. Sometimes we're building an extraction facility in an already established warehouse.
Yeah. So here's a little bit more detail of what I mean when I say the layout process again. You really need to understand what your chemical specifications are. You need to really understand what those critical processes are. We just talked about that.
Yep.
There's something that I want to introduce you called the basis of design, and that really has to do with looking back at the codes, the building codes, the hygienic codes, the fire codes, the GMP codes, looking at those and using those for your basis of design. In other words, here's what we're designing off of.
You already have to know what you're going to be doing and planning for and able to.
So NFPA code for those of you who are in the U.S. for fire, or you have international building codes, you have international fire codes.
Yep.
Those are things that need to go in there. GMP Q7 obviously it talks about the building, talks about maintenance, talks about equipment, it talks about flows, all that stuff.
Oh, yeah.
So that becomes a part of the basis of design. You have hygienic codes related to how a building is fabricated.
Yep.
For example, does it have a lot of horizontals associated with it that could accumulate contamination over time, right?
Right.
Either you have to put in a process by which you maintain your property if it does have some accumulatory type of items, or you have to build it to that standard ahead of time.
So it's not going to affect it.
It's better to build it ahead of time, in fact. In some cases, some of the qualifying bodies have disallowed buildings
that already exist.
That already exist, because there's no way to make it into a hygienic building unless you go in and do remediation on it. There's, so
scrape the lead paint off the walls and tear
get
out the asbestos. Man, that's the good stuff though.
Make sure you get away from the Dow chemical plant next door.
Man, that just makes it stronger.
Or make sure you're not downstream from an ethanol extraction facility.
Yeah, that's
lots of VOC going up in the air there.
They're just putting that hemp right outside.
All that stuff going on, all that smog that's being formed by those guys. Yeah, don't be that guy.
Don't be that guy.
Don't be that
guy.
guy.
We're working to change it. We're trying to make it easy for you.
You know what? We're supposed to be going back and helping the environment by
doing
also ourselves and more natural ways of going about doing things, and then we end up, because we think we're saving money, which we're not, because the equipment, it maybe costs you like 20% less. So you're gonna destroy the environment.
Right.
You're gonna destroy the environment so that you can.
And that says a lot about you're right, the person that's running that type of company. I mean, consumers are looking at that stuff more and more as time goes on. So.
Anyway, getting back to that basis of design.
It's so easy to get off topic.
Yeah, when you go into the basis of design, it's just a set of codes. And usually when you look at a plan, maybe the first 6 or 7 pages, just a bunch of writing. Well, that's where the basis of design is at.
Okay.
And that's where
they're laying it all out. Gotcha.
And the plan that comes after that basis of design should correspond with that basis of design.
Yeah.
If it violates it, there has to be something else, like a different exception that maybe has to be a note in there that says, okay, this takes place with process and the equipment. Sometimes complying with it is impossible with just straight up layout and design. So conceptual layout, we get the conceptual layout, we do the design review, and then we do the detail layout. So very similar to what I just talked about, but it's really important that you get the stakeholders right.
Yep.
And typically you want to have more than one person. You don't want to have just the subject matter expert.
Put all your eggs in one basket.
No,
it's
yeah,
not a good
exactly,
idea here.
no.
Oh,
You got to have
man.
that QA person there.
How are they going to save money if they got to hire 10 different guys?
10,
No, that's
15
the,
people.
but
That's the
thing.
problem. Okay, we're just starting out. We got 2 people. We're going to do a GMP. Okay, who's your QA person? Who's your architect? Who's your subject matter expert? Where's your process engineer? And they're like, oh, we don't have any of that right yet. Okay, we're just going to get going and we'll be GMP
Right.
and whatever. I think you can, there's no GMP light, right? That's what a lot of people say. Oh, GMP light, it's not, it looks like GMP. Either you can pass the muster of going through the process or you can't.
Yeah.
These are the types of the people that you need to have on your team.
Yeah.
Obviously. You need to have an architect, because the architect's is different than the designer.
Right.
The designer is going to take into account all the process. They're going to take into account the utilities, the equipment, where it all goes, all that stuff. But they're not going to really do the architectural work, which is really defining
how many feet of pipe they need to,
how many
or does that kind of fall
the designer
into the layout?
would do some of that work, but he wouldn't probably do anything like defining all the hygienical aspects of the facility, the surface finishes, all the details of the offices and stairs, and typically an architect will also work with MEP engineer, which is a mechanical mechanical, electrical, and plumbing.
Okay.
That's an engineered plan that goes with the architectural plan, which is the layout and all that stuff. Yeah, so you can see you do need a team. It's going to run into some cash as soon as you do this. We built stuff without drawings before.
It's happened once or twice.
Oh, we did, yeah. And it's difficult. I would say that
it adds a level
what
of
ends up happening
complication.
is you end up having to build it twice.
Go back and fix things and
so design build. That's where basically you have no plan and you're just going in there saying, hey, go do this one. That's a really good way to spend $1 million on electrical or whatever.
Yeah.
It's almost better to have the plan, and then you can understand what your costs are going to be and get quotes and things like that. So
makes it easy.
Define layout scope. Okay. Well, there's process areas and then there's non-process areas. So you got your utilities areas. These are not really controlled areas. Okay. Your gowning rooms.
Okay.
Your laboratories, they're not necessarily controlled like from a GMP standpoint. Remember we had talked about the levels of control a couple weeks ago? That's basically, so the levels of control are if there's exposure of the API to the atmosphere, it has to be controlled. In other words, the surface has to be closed, the building has to be, the room has to be controlled. And so so then you define all those levels of control and what that means in terms of the surface finishes, what that means in terms of the ceilings, the windows, all that stuff. And then the pressurization in the room, the level of filtration in the room, all that stuff. Okay.
Yep.
These non-process areas typically are like level 1 areas. In other words, there's no control. They don't really have any items. You just got to keep it clean, that type of thing. So and then maybe an exception would be in this dispensing, filling, sampling room. These ones can be like level 3.
A little bit more control.
If you have your API going in there and it's being exposed to the atmosphere, then that would be a level 3 room. A level 2 room is a protected corridor between a level 1 room and a level 3 room.
Okay.
So a level 3 room is the highest stage of a room. So obviously break rooms, offices, staircases, even technical rooms wouldn't be considered. It would also be level 1. Quarantine, as long as you're quarantining your product storage, as long as you don't have exposure or open exposure to the raw material or a possibility of cross-contamination between raw material and intermediates or intermediates and the API, as long as it's all contained, you can be considered level 1. Okay. A good example, like we've been doing some silo work for hemp and all of that, dealing with lots of, that's all contained. So it actually can be outside even.
Yeah, but it's enclosed within its own area.
Exactly, so it's all enclosed. Pallets that are wrapped, marked, typically barcoded, also would meet those container solvent storage. So anyway, there's lots of different things, but when you think about the layout, you need to be thinking about, okay, what are my process areas that are corresponding to my critical processes and non-critical processes, and then also those support areas and how they interact together. So it's a little bit of work to really think about all that. And there's a couple tools that you would use. You'd use, typically what we do is an accommodation schedule, which I'll talk to you about what that is. It's just a bubble map of how things interact together with the given processes. And sometimes, like we have many different clients, and they may have different like one of them might get in distillate and then just be packaging it.
Yep.
Or
Making
one of them
finished
might
products.
be making it, bringing it to isolate and shipping that. And so there's,
That's their
depending on
end
the
product.
workflow,
Right.
you can have different accommodation schedules. You can have different conceptual layouts and different
Right.
equipment layouts. This would be an example of an accommodation schedule here. And you know, what it does, you can see it's just very simple. This is a very simple one, but
They get trickier than this?
they get trickier
Oh,
than this.
man.
But you know what's important about it is you can understand, okay, here's the adjacencies,
Yep.
here's the materials coming in, here's the flow, you know, how you're going to bring the material in, what is required, does it require to go through airlocks or not?
Right.
Where's the utilities getting in? Where's the control room at? How's the people interacting with, for example, the control rooms and the lockers and things like that? It's just a very nice, easy way to say, okay, here's my process. Like we said, there's different processes for different people,
Yep.
right? So that this is going to change depending on
What you're doing.
what you're going to do,
Yeah.
and then also it's going to change based on your risk assessment
Yep.
that you do. Okay,
Absolutely.
and people assess risk in different ways. That's why you need inspectors there to take a look at it. And there's no such thing as one size fits all on all of that.
No.
So yeah, anyway, so it defines the interrelationships between process, material, utilities, and personnel. Okay, so obviously here we have no interaction between utilities. That's not actually how it is. There's glycol units that typically go in and out of a room. There's HVAC that typically goes in and out of a room, whether it's a
Yeah.
hood or filtered
Simple
air.
venting.
Yeah.
Even simple
I mean,
venting.
we got venting. That'd be a good one. What else we got? We got pneumatics or vacuum. Maybe you don't put the vacuum inside of the room. Sometimes people do, but
Yep.
it's better if it's outside the room. And you just pipe it in, that type of thing. I think we hit a lot of them,
Yeah.
what kind of utilities, but some of the utilities can get very complicated. Oh, cryogenics, like with CO2, right?
Okay, yeah.
So like a typical extractor would have a cryogenics loop, it'd have a glycol loop, it'd have some maybe heating boiler loop.
Yep.
It might have air loop for all the valves. It might have a venting loop, right?
Yeah.
So you have just basically 5 or 6 process connections, including the electrical, just for
That
one
are
piece of equipment.
Just for that one.
Yeah, so you got to know what you're doing. And then those things, there's also proximity requirements for those. Okay, this has to be this close and it can't be this far away. But it
Right.
can,
Before it's not
like I was saying.
effective, yeah.
Before it's not effective.
Yeah, you don't want to put your vacuum pump
Right.
50, 100 feet away from
So that's
your-
what an adjacency matrix is.
All right.
In that just basically, I give you a small example here of what an adjacent matrix would look like. It would get much more detailed than this. And you would also put on things in here. You'd probably put in here like gowning areas.
Yeah. That's
You
definitely
put
an
in
important
there
step.
maybe the control room. You'd put in there a material airlock or a personnel airlock or whatever, right?
Yeah.
So you do all of those things. You put those all in there, and you just put one. You would put one versus the other, and then obviously the slope here would always be X, and you just say, okay, is the proximity required? Like for example, grinding and extraction. Well, is it required? Probably not, but it's important that it's close.
For efficiency.
Yeah, like you're not gonna trumps around with raw material coming out of your grinder.
Oh, bring in the dusty grinding
Yeah,
material through the distillation room, through the solvent
distillation
removal.
room, through the solvent room. Yeah, so you can see here in this case, the grinding, it's desirable that it's close to the grinding, the extraction, okay, but it's very undesirable if it's close to distillation formulation. And you don't want to have personnel entrances in your grinding area either.
Letting the
because then
dust
they're
in and
going to be
out.
getting stuff on their feet.
Yeah.
Or whatever, or maybe dust.
And carrying
okay.
it to other areas.
Carrying
of
it to other areas. And so you want to make sure that, this is pretty much common sense, guys. If you do the adjacency matrix and the accommodation schedule,
Yep.
these two things really work together to give you what you need to do like an initial conceptual layout. So you
Okay.
can know how everything is. So we've had engineers, they're like, okay, here's what they'll do. They'll say, oh, I've done lots of GMP engineering. I know everything about it, okay? I've done pharmaceutical facilities around the world, okay?
Yep.
Great, good for you. Okay, so I can do everything. So they go in there. They don't do the adjacency matrix with us.
Oh, yeah.
They're like, okay, how much have you really done it? You don't even have,
They have a
you're
very-
not even asking the right questions.
very
Okay,
narrow
but
scope.
whatever,
Yeah.
exactly. They didn't do for example, the accommodation schedule with the equipment and the personnel and the process, and then they haven't done the risk assessment, so they're just going in there, blowing a lot of smoke, actually.
Right.
And at the end of the day, you have to make sure that that these things are taken into account.
Yep.
One of the things that really a subject matter expert would really rely or really bring to the table would be like maintenance, where you do maintenance areas, and then cleaning areas, introduction of SIP or CIP systems, clean in place systems for how that's done, and where all that stuff should be housed relative to the process. So you really do need to have the conversation. You really do need to really make up your adjacency matrix. You really do need to do your accommodation schedule, because if you don't do that and then you do the design, you're going to be doing it again. Yeah. And then you're going to do it again. Or it's going to be even, I just took responsibility for doing all the process. We don't care. We're just delivering equipment. Boom. You throw it in there. It doesn't work. Oh, that's not our problem. You want us to commission that? That's not our problem. Come back and we can commission items, but it has to be, if it doesn't work.
It has to be certain specifications. Yeah. Sometimes.
So if the door is too small, you obviously didn't get the plan done.
Which has been an issue.
Yeah.
That sometimes happened in the past.
If you're not taking into account the fire requirements, also you have also, there's another levels of control that are beyond GMP control. They come from the basis of design, which are the IFC, International Fire Code, or NFPA, or Canada has theirs, and every country has their own one, and the EU has theirs. At the end of the day, you need to be able to take all that into account. So here's just some very simple conceptual layout items. Here you can see a facility here, and you can see this is the material flow. You can see the materials flowing here. It looks like there's a material corridor here. I would say that this is some sort of airlock here. It looks like it's pretty nice in this case because the personnel flow here is coming through a personnel corridor. It looks like there's another corridor here.
Just for
material. So you can see there's separation of material and flow, and it looks like there's some sort of, you see these double arrows here. It looks like there's some sort of airlocking going on.
Yep.
You can see here, this is where, it doesn't really show anything related to what these boxes are.
Right.
You probably have somewhere here where you'd have gowning going on.
Right. That's probably where that initial spot is. Yeah, it could be anywhere. It looks like, where the people are congregating. That's probably where a lot of the production goes on. When it gets finished, it's pushed to the outside. So
I'd give this plan definitely an A because it's got some good thoughts on it. What's missing from it is myriad. It's got a lot of stuff missing. Where are the control rooms? Where are the utility rooms? How are those interacting? It's missing. Where are the gowning rooms? Where are the people coming in? All of that.
We can't give it all to them for free.
No, right, exactly. So anyway, so that would be a good way to take an adjacency matrix.
Yep.
And then you would take your interaction matrix and the accommodation schedule, and you would lay on top of this now the utilities. And you would lay on top of that the HVAC. Now, the HVAC is basically, where's the flow of air happening? Yeah. The way I like to do it is I like to think about this plan, and I like to, where's the possibility of dust occurring? Yeah. So then in that area, if it's intermittent dust or whatever, in that area, I like to put it under a negative pressure, and then I like to then design or conceptually lay out what that HVAC might look like with those negative areas of pressure.
It's all being built around that.
Yeah, you probably don't want to have, for example, your solvent areas, if there's any solvent exposure at all, you wouldn't want to have that under a positive pressure because it would blow out the solvent out into the other rooms and then it would contaminate the other areas. Right. So those are some other places where relative to the hallways that suppose you have a solvent area right here, for example, in this purple area, you probably would want to have maybe this positive pressure and maybe this just a positive pressure. So and typically what the HVAC engineer would do is they take that design then and say, this is what I need to think about, and then they would specify the relative pressures for each of the rooms. So it works together.
Nice.
Yeah. Then you have obviously the levels of protection, whether it's general protected, and then you can see here there's flammable control areas. Those are also general areas you need to think about. In this case, this looks like a general storage area. These looks like they're unprotected areas. They're not under, so they would have a list of surface finishes and requirements for level 1 areas.
Okay.
And then as you go in, it looks like, level 2 areas are feeding these level 3 areas you can see here. So obviously, this is why your adjacency matrix has to happen. You can't have this level 1 area feed a level 3 area because you're just going to continuously contaminate your level 3 area.
Yeah.
So that's why adjacency matrix matters. That's why you need to really think about those things.
The whole process,
the whole process into it. Yeah. That's why you need a subject matter expert like us.
Yep, absolutely.
We do this stuff, right?
all day.
Yeah, and I have to say that some plans are really difficult, maybe because there's not enough room.
Oh, yeah. Trying to cram too much in too small of an area.
And the Q7 says you really need to have an adequate space to run your facility. There are some critical dimensions associated with the equipment that you, like, for example, you have to have 2 feet around or 3 feet clearance with some pieces of C1D2 equipment, for example. You can't just stick it up against the wall, okay, and then say, hey, I got enough room. And if you only got a 10-foot by 10-foot room and you got a piece of equipment that's 3 foot that's sticking out from the wall 3 foot, that means you only have 4 foot, 5 foot left on the one side. So you are 4 foot left. Okay, that's not enough room to actually do a process in there. So you need to have enough space in order to get that done. So that's something to think about. So speaking of layout considerations, here are just some things that are on the top of my head. Site, obviously, we talked about that. You don't want to put your place next to a cyanide plant or a pig farm or downstream of the prevailing wind from a Dow chemical plant.
Right,
Or in a place where there's heavy amounts of smog because there's too many ethanol extraction guys in there. Extraction hygienic building, for example, that's one thing you need to think about. And we talked a little bit about some of the principles there.
Yeah.
And I think last week, James and I, we talked a lot about just the requirements for hygienic building.
Yeah.
I don't think that any of these things are like hard rules. Like you absolutely have to have them.
Yeah.
But there are some things that you need to be just thinking about.
Oh, so always.
That is. And if you
haven't done it before, you don't think about that.
Yeah, exactly.
You just see a cheap piece of land down the way from Dow.
Exactly.
Look, let me just throw up a...
We're on top of a super fun site. Process operations. Okay, that's something you need to think about. Obviously, your capacity. We do a lot of that. Okay, hey, look. We're going to take the plan and we're going to break it up into 3 phases or 2 phases.
Yeah.
Maybe for its budgetary purposes. And you'll have a certain capacity, a certain scale at phase 1, but we want to build for a scale, like a certain scale that we think we're going to be in year 3. You don't want to have to switch the building halfway through because you don't have enough room or whatever. That happens.
Yeah.
And then you're not able to...
It's an expensive mistake.
Yeah, it's a really expensive mistake. You're building the place out and it's too small.
It's not going to work for your needs, and then you got to build a new facility. Yeah.
A lot of this also has to do with what your general philosophies associated with automation. If I'm going to be like Uber automator guy, I'm probably going to have a different facility than if I don't mind
manual
discontinuous
processes.
Yeah, one thing that we've been doing is putting all of our processes together. For example, extraction all the way through distillation.
Oh,
so there's no...
Are they ready to hear about that?
Are
they ready to hear about that continuous processing?
Exactly. So you get it out. We could bring it all the way through. What would be great is if you could put the stuff in one side and then it would roll out the other side like a vapor pen or something.
Just the pen comes out.
That would be really nice. Okay, that's impractical, but unless you're selling billions of vapor pens, which you're not, right? But at the end of the day, typically so many things you can automate within a process to really reduce or eliminate handling. That's what you're really looking.
Yep.
And also to reduce those level 3 areas.
Okay.
Which are expensive, right?
Yeah.
So if you have a continuous process and you can put that all in one level 3 area, then you're fine.
Yeah, that's going to save a little bit of money.
So your extraction, you can put in one area and then pipe it to a different area and have it finish up.
And nobody has to essentially touch it until it comes out.
One of the things that you want to make sure is you try to minimize overhead piping, because some of that piping can get full of dust.
Oh yeah,
stuff like that, or
yeah.
even condensation if it's not insulated.
Right.
You should insulate everything, because that would have microbial growth too.
Exactly.
But yeah, or if those pipes are up there, you should probably put them with a cover, PVC cover,
so they're held
and
in.
then have a maintenance schedule that cleans them on a maintenance schedule.
Yeah, that would make sense.
Things like that. I noticed that our pipes that we have out in our facility, they're PVC coated, okay, and then there's SLP in there that goes in for maintenance to clean them off.
Right, at certain intervals.
Yeah,
and,
exactly.
Yep, certain
so
chemicals
there are
to
exposed
use.
pipes, but they're in level 1 areas. They're not in level 3 areas.
Affecting any of the product.
Yeah, so, yeah, exactly. Contamination, obviously, is something you're going to need to consider. Utilities, cleaning, maintenance, these are the things that you need to consider when you're talking about your layout plan. Material and equipment flows. These are just some principles. The Q7 talks about prevention of mix-ups. I have done designs where it was so constrained, there was no possibility of having a material and personnel flow.
Okay.
And the way the rooms were, it was like, okay, all of the inputs and outputs were going through the same corridor, personnel and material. So when you do your personnel and material flow, all the arrows are overlapping.
I gotcha. Yep. How they were all separate. In that
Right.
first.
Oh, yeah, here's one right here. This is obviously, that's a bad layout.
Yeah, there's a lot going on in a little area there.
Yeah, so part of the issue with this particular layout was it was too constrained, and also I hadn't gotten information on where utilities needed to be and things like that.
Yeah.
That's just some different things you can see here. The idea here, again, you would put in a material and personnel flow corridors, much easier to do, and then you have different square footages associated with that. Here's some other different ways. You have personnel coming in from the bottom. You can do these block diagrams to get to the idea of, okay, here's a bunch of options.
Right.
Because getting into the engineering and getting all the engineering for each one of those options would be impossible.
Right.
You'd be spending weeks and weeks.
Very time
You'd never get
consuming,
anything done. Yeah, so that's basically how that all goes. So there's the material and equipment flows. Separation of raw materials from intermediates and final products. Okay, raw material in our case would be like hemp or some botanical, whether it's mushrooms or whether it's bark or any other raw material that's coming in that's not the API that's coming out, would be the extract.
Yep.
Or would be a distillate or something like that. You really need to have separation of those. I would separate out, for example, the receiving stations even. So where it's being received. If you're going to have excipients come in, I wouldn't necessarily, if you have an option to bring in your excipients from your raw materials in separate areas. Certainly storage. You don't want to have your raw materials stored next to your excipients. Your solvents, your excipients, your packaging, any of that stuff. First of all, it smells so good in here. I mean, but all that's going to get infused into your package, all those beautiful aromas and stuff like that.
Yeah.
So use corridors, airlocks to distinguish between the levels. Yeah, that stuff, all that smell would actually get into your beautiful packaging, right?
Yeah.
Someone may consider that to be contamination. I mean, I wouldn't.
Yeah,
I would.
No. But yeah, no, I could see you don't want to.
Like this box smells like weed. Okay, so then you try to ship it somewhere, and the box smells like terpenes. So that's something you got to think about, and especially with the aromatic nature of botanicals, that tends to permeate everywhere. So you need to make sure that things are protected.
Yep.
And you do the airlocks for that. Also, multi-product facilities. We just named a whole bunch of different botanicals that could run through one particular extraction facility. So those are multi-use facilities. Those have very specific, special requirements that you need to be thinking about, have to do with how you're separating out those materials from everything else, where you're storing them, how you're quarantining them, and all
cleaning
that
the
stuff.
machine.
Yeah, all the cleaning. Cross-contamination on your machine.
Yeah.
Single versus double wave flow. That's something that we had showed you before with that crazy diagram.
Oh, yeah.
That wasn't my finest hour, actually, when I did that one.
Late at night.
I was like, oh, this is the only way. I sometimes, when I do some work, sometimes I will just sit there and think about it. And it maybe take me a couple hours, like, what is the best way? Sometimes, because if you have a whole building, you're going to have a portion of the building, And oftentimes it's connected to a grow. So you need to really understand about, okay, where's your material coming in?
Yeah.
And,
Adds a whole nother layer of complication.
some
and
of them
setting that
have really, basically because it's so small, usually you have problems when things gets really small.
Yeah.
You can never have too much room, by the way.
No,
It
no.
just seems like that. People want to put them into really small areas, and it's actually violating the GMP principle of having enough
Well,
space
like you
to
said,
actually operate.
2-3
right?
feet between the
Yeah.
pieces of equipment
Yeah,
and
so-
walls and
Sometimes what people do is or designers, what they'll do is they'll create a level 3 room, and then they'll pull out the equipment and put different equipment in there. And
no, why would they?
Well,
wouldn't
because
they have to?
Because they can do different processes in the same room, and that room
just
costs
because
them a lot
it's
of money.
level 3. I gotcha.
So a lot of
Wow.
times, in that case, you need to have an idea about equipment storage and where to store it. You'd have to have that thought out way ahead of time. like,
Right.
okay, I'm going to do this.
Are
Some
you
people with
storing it?
smaller facilities, you may want to have those things and then have multiple utility hookups in there, right?
Yeah.
So anyway, personnel flow, just some ideas there for you guys. Usually you would create a gowning level schedule.
Right. Gowning schedule.
Yeah, we have a gowning level schedule. We do that all the time. You go out to eat or
What?
whatever you're going out to. A gowning level, pajamas, okay? You don't go out to eat with pajamas, and maybe some people do.
No. I haven't
guess
in a while.
when I was
I
back in
guess.
college,
Yeah, I was
they
going to say,
did.
yeah, maybe when I was younger, there's some.
There was no gowning code there. There was no hygienic code there either, from what I remember. That was something else.
some loose.
Yeah, the gowning levels. So typically what we would do is every room would have its own set of gowning level requirements, and sometimes you can group those. So gowning level 1, gowning level 2, gowning level 3,
Okay.
things like that.
Yeah. Depending on how
Yeah.
close in contact
You have to
they're
have
coming with the
like,
API
for example,
or whatever.
Yeah. So if you're out in the warehouse and you're doing raw materials, you're doing forklifts,
Yep.
steel toe boots, gloves. Maybe you're not in your street clothes; you're in a different, set of clothes. Okay?
Yeah. Not,
But if you're in a level 3 area, you might have booty covers,
yep. Hairnet, beard
beard gloves, all that stuff. Yeah. So there's different levels of control, and
Yep.
you may have respirators or
Oh, yeah.
whatever. Yeah. Interlocks are another thing. Training on gowning levels, signs, things like that you need to have in your personnel flow. And then facility construction issues. I'm almost done with this, guys. This is I could talk about this for a long time. I'm telling you.
He's done it before.
So
No, I'm
type of
kidding.
construction, safety classification. In other words, one of the things that people don't realize is that if you have lots of ethanol in your facility, you may be classified as a hazardous H1, H2, H3 hazardous occupancy.
Right.
Usually you want to reduce the requirement for your building by going into an F occupancy or a general industrial occupancy. That makes sense. Egress is another thing that you need to think about, X-proofing, lighting, draining, pest control. These are things that we address in our designs and in our design protocols, and then waste manifest and security. Actually, our design offering is by far the greatest deal.
Yeah, everybody that gets them absolutely loves them because
Yeah.
I don't think they expect all the information that we actually provide.
Yeah, so it's a lot. It's too much. I don't think the price can really, because we're paying engineers, but at the end of the day, you're getting a good design, you're getting a good plan, and so on
Absolutely.
and so forth. It's very important that you have a good subject matter expert
Yeah.
working with you
Absolutely.
on that. And it's not just pharma, it's also process. And it's not just process, it's also specific equipment know-how. You can see how that all would have a huge impact on your design.
Definitely.
You
Definitely.
know, and yeah, so if you have a process designer and they're working with their architect and you say, hey, where's your adjacency matrix? And they go, huh? Then maybe you got the wrong guy. If you are working with your designer and you're working with your subject matter expert and your quality control people, and there's no conceptual drawing of interactivity diagram.
Right.
A lot of people will call it that. You probably need to think about that because that's the very basis of what you're doing. And if you don't have your risk assessment done, but you kind of need to get that done. You need to be thinking about that with your subject matter expert. They're going to be bringing that knowledge to the table and saying, hey, here's what I've seen in the past. Here's why this is critical.
Yeah.
You really have to really understand what those critical processes, critical units are and everything. So hope that helped, guys. Hope that helped.
I think it helped a few people out there. We get a few calls every week about people looking for this kind of
yeah,
stuff.
Yeah,
so.
exactly. I think we've done the number of plans that we've done have just skyrocketed. So lots of plans going out. People like it. And
well, because again, it just
I personally check the drawings. I don't know if that will continue because I'm spending a lot of time doing that. But I want to make sure that it's perfect. I'm a man of simple taste, easily satisfied with the very best. Kind of like that.
Yeah.
Or just perfection or whatever you want to call it. And that's why I got you guys working here.
Absolutely.
That's why I'm lucky to know you. All right. Thanks a lot, guys. Appreciate it. Any other questions or concerns, you can bring them up with Jared here, and he'll answer all your questions.
Absolutely. Reach out anytime.
Yeah. And same thing with James O here. He doesn't answer the phone. We keep him in the back.
No. But you guys can leave him a comment on YouTube. He loves reading those. He loves interacting.
That's true.
Don't be afraid to make him blush.
That's all right.
No, I'm kidding. But no, definitely YouTube's been a big help. A lot of people are going to that as well.
Yeah,
and information. That's where you can find this podcast as well as on the website.
Exactly.
Tons of stuff.
We're all set. All right. Thanks a lot, guys. Take care. See you later.
Oh, I didn't know if we were coming in for the...
Yeah, I was coming in for both. High five.
The wave.
Oh, man, the wave. It's all good. See you later, guys.
Bye.
Bye.